Find the sum, express the answer as a simplified rational expression, and state the domain. So we have these two rational expressions, or two fractions, if you will. And whenever we add fractions, we need to find a common denominator. And the common denominator has to be something that's divisible by both of these denominators. And in general, we want to find the least common, or the least common multiple of these numbers, or the smallest number that's divisible by both. And when you look at it immediately, it might pop out at you like, hey, you know what? Gee, 6 is divisible by 3. And x to the fourth is definitely divisible by x squared. So 6x to the fourth is definitely divisible by 3x squared. And of course, it's divisible by itself. So this actually is the least common multiple. This is the smallest number. This is the smallest number, or the smallest expression, I guess, that is divisible by both 6x to the fourth and 3x squared. So let's make that the common denominator. So this sum is going to be equal to 5 over 6x fourth plus, and now what we want to do is write this with 6x fourth as the denominator. So let me just write it again. So plus 7 over 3x squared. So how do we make a 3x squared into a 6x to the fourth? Well, we're going to have to multiply it times 2 to make the 3 into a 6. And then we're going to have to multiply it times another x squared. So we're going to have to multiply it by 2x squared. Now, we can't just multiply only the denominator by 2x squared. That'll fundamentally change the value of this expression. We can only multiply it by 1. So let's multiply it by 2x squared over 2x squared. And we're assuming here that x is not equal to 0. X does not equal to 0. And that was actually a safe assumption to make, that that 0 is not a member of our domain right from the get-go, because that would have made either of these expressions undefined. So if we assume x is not equal to 0, we can we can multiply by 2x squared over 2x squared. And then that will give us, so this will give us the expression 5 over 6x to the fourth plus, this becomes 7 times 2 is 14, 14x squared over 3 times 2 is 6. X to the squared times x squared is x fourth. So now we have a common denominator. The common denominator is 6x to the fourth. And we can just add the numerators. So it's 5 plus 14x squared. Or I like to write the higher degree term first, or 14x squared plus 5. And we are assuming that x does not equal 0, because this would make the expression undefined. And that's about as simple as we can make it. We can't divide, 14 is divisible by 2, and so is 6, but 5 isn't. So we can't divide everything by 2. And then there's x squared, x to the fourth, but 5 has no x term on it, so we can't divide everything by x or power of x. So we're done. It's 14x squared plus 5 over 6x to the fourth, and x cannot be equal to 0.